Boys, they went to Adisyam. Live போகிறோம் நடக்கணுமா கம்பல்சரி. Okay. So group 15. Okay. Okay. Next 23. Okay. The next important. So, for example, in earth crust. Okay. Please. There are two. One is going to be okay, phosphorus. So the minerals of phosphorus is going to be the minerals of apatite family. Please note this. So phosphorus is going to be the minerals of apatite family. Is it clear? The formula is going to be calcium. Phosphorus is going to be and the phosphate is going to be 6 times calcium X2. This is the apatite formula. Calcium 9 times phosphate dot calcium malate. In this case, X is going to be either F, Cl or 6 times. This is important. Apatite family general formula is going to be calcium phosphate dot calcium phosphate. Particularly example suppose fluoroapatite. Fluoroapatite. Okay, so what is the formula for fluoroapatite? So calcium phosphate. This goes 6 times calcium X க்கு பதிலா. This is called fluoroapatite. Fluoroapatite. Fluoroapatite அப்படினா X க்கு பதிலா F, Cl அப்படினா chloroapatite, OH அப்படினா hydroxyapatite. Is it clear? So this is general formula for. So these are the minerals of phosphorus. Is it clear? Next we have arsenic. Arsenic, antimony, and bismuth. So this mainly occurs as a sulfide minerals. mainly occurs as a sulfide. Mainly occurs as a sulfide. Is it clear? So these are the points that you have to remember. Is it clear? So next we will go for the properties. You just copy this one. What is the formula? Apatite formula. This is general formula. Chlorooperator. These are minerals of phosphorus. Okay, so that's the point. So you might have noticed this apatite in toothpaste. Paste la pathina and there are component. Okay, so you just note this. The next is going to be properties. First is we are going to discuss about atomic properties. Atomic properties. Okay, atomic properties. First, we are going to discuss about atomic and ionic radiation. Atomic and ionic radiation. This is clear. So, atomic and ionic radiation. This is general property. Left to right pona. Atomic radius decreases, down the group on the atomic radius is going to be increases. Is it clear? So down the group on the from phosphorus to bismuth. Okay. The atomic number increases as well as size also, radius also increases because down the group now radius increases. Okay, so nitrogen to bismuth. Atomic number increases as well as the size increases because atomic radius is directly proportional to n. Principal quantum number increase radius increase. Is it clear? But your trend regular trend because n contributions we have a D and F because D as well as F. For regular decrease and increase for example, suppose you take from arsenic, okay, from arsenic to bismuth, okay, there is a small increase in radius, because of any reason. In the case of S-block elements, regular increase. For example, you take lithium, sodium, potassium, rubidium, cesium. This is a regular increase. Is it clear? That means there is no intervention of F and D orbitals. Whereas in the case of this one, arsenic electronic configuration is going to be, what is the electronic configuration I will tell? Arsenic argon 310 310 problem. Clear? 4F problem. Is it clear? Contribution poor shielding of D orbital, poor shielding of F orbital. Size now vast decrease increase. Vast increase. Is it clear? Difference for example, suppose 100 picometers, 102 picometers or 110, 20, 50 because of n factor poor size decrease reason shielding effect. Is it clear? Because of poor shielding of D and F orbital electrons. The small increase in size or radius because of poor shielding of D and F. Is it clear? Yes. Whereas start D and F start down? Arsenic, antimony and bismuth. That's D. Regular increase, vast increase. D and F contribute or size is going to be smaller increase. There is a point. Next, second point is going to be ionization enthalpy. It's very, very important. I ionization enthalpy, this already we have discussed, because general electronic configuration ns2 np3, this is going to be half-filled electronic configurations. Half-filled electronic configurations are more stable. Half-filled electronic configurations are more stable. Is it clear? Ionization energy, obviously ionization energy is going to be directly proportional to half-filled as well as completely filled electronic configurations. Ionization energy is directly proportional to half-filled and completely electronic configurations. So for example, suppose you take group 15 and group 16. Group 15 and group 16, which one will have more ionization energy? Group 15 elements and group 16, either more ionization energy. 15 because of half-filled. Is it clear? Because of half-filled. And you might have studied this trend, right? What is the trend? Lithium, boron, beryllium. Next we have carbon. Next we have oxygen, nitrogen, then fluorine. Please note this trend. In the case of secondary element, is it clear? Actually, oxygen, it has a low ionization energy because this is going to be 2s to 2p4. This is going to be 2s to 2p3. This has more ionization energy, followed by nitrogen and oxygen, carbon. This is going to be s orbital, and this is the trend in the case of first ionization energy. Please note this. This is the second period elements. Generally, if we compare group 15 and 16, which one will have more ionization energy? Obviously, group 15 when compared to group 16. Is it clear? Because of half-filled electronic configurations. Half-filled electronic configurations. Okay, next. Yes, if you want, you can note down the electronegativity value. Ionization energy values. Okay, ionization energy is going to be decreases down. Okay, decreases down to the group. There you go. Decrease. If you move from left to right, this is the trend. Whereas down to the group, ionization energy decreases because ionization energy inversely proportional to atomic size. Okay, down to the group, ionization energy decreases. This is my general trend. Is it clear? So this is the point that you have to note down. Next, electronegativity. Electronegativity. Okay, electronegativity. What does it mean by electronegativity? Electronegativity. What does it mean by electronegativity? Tendency of an atom to pull the shared electron towards itself. Is it clear? This is the tendency of an atom. For example, so electronegativity, what is the general trend? Left to right. Left to right electronegativity increases. General trend. Left to right electronegativity increases. Down the group on the top to bottom. Top to bottom. Generally, electronegativity, this is a general trend. Electronegativity decreases. Okay, electronegativity decreases. For example, in the case of group 15, we have a nitrogen, phosphorus, arsenic, antimony, and bismuth. If you go to Pauling scale, electronegativity scale is going to be 3.0. This one is going to be 2.1. And this is going to be 2.0. And this is going to be a 1.9. And this is going to be a 1.9. So please note this. Electronegativity of these two is going to be same. The value is going to be 1.9 and 1.9. Okay. Okay, so the question is electronegativity values of antimony and bismuth, the value is going to be 1.9 and 1.9. Okay, next, please note those physical properties. It's very important. So electronegativity value is what on what scale? Based on what scale? This value is based on Pauling scale. In a scale? Pauling scale. Is it clear? So please know this. So for example, you might have studied this one: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. How to remember this value? How to remember? You have to start this one from 1. Electronegativity. This is going to be, you have to increase 0.5. 1.5. This is going to be 2. 2.5. This is going to be 3. 3.5. 4. Okay. Next is sodium. Okay. Sodium, magnesium, okay. Aluminum, silicon, phosphorus, sulfur. Is it clear? So in this case, you have to start from 0.9 down the group, decrease on electronegativity. So you have to increase 0.3. 0.3 now, magnesium 1.2, 1.5, 1.8, 2.1. Is it clear? In the phosphorus, you have to pass. Phosphorus, you have to pass. That is 0.3. Is it clear? Next, this one is going to be 2.5. You have to pass. That's 0.3 increase. Is it clear? This is going to be 2.5. This is going to be 3. This way you have to remember this. Phosphorus, you have to pass. Just remember, you have to pass. 0.3 increase. Next, this is going to be 2.5. This is going to be 3. Is it clear? So next thing here, this is going to be O. This is going to be I. You know the value? This is going to be 2.8. This is going to be 2.5. Please know this. Okay, so this you have to remember. Okay, please remember these values. Okay, so which one will have the same electronegativity value? In this case, number 2 point. What about the hydrogen electronegativity value? 2.2. Hydrogen and phosphorus, they have the same electronegativity value. Phosphorus and hydrogen, they have the same electronegativity value. Okay, so these are the points that you have to remember. Again, this is also periodic properties. Periodic properties. Next, we are going to discuss about physical properties. Okay, physical properties. Physical properties. Okay, physical. So everything as a data, you have to, every point as a data. Every point you have to note down. Is it clear? For example, so we know that nitrogen, okay, nitrogen is going to be always going to be a diatomic gas. Diatomic gas. Always exists as a N2. Okay, diatomic gas. And whereas this gas, diatomic important, always is going to be N2. But suppose if you go to the low temperature, nitrogen can be converted as a liquid. Is it clear? Next, the other elements are, for example, phosphorus. This is going to be polyatomic. Okay, polyatomic, and it's going to be a solid. For example, phosphorus, exists on P4. Okay, so in this case, the atomicity is going to be phosphorus. That is, atomicity is going to be 4. Okay, atomicity is going to be 4. Similarly, the other elements also. Arsenic AS4, that's polyatomic. Whereas nitrogen exists on diatomic. Okay, that's the gas. Is it clear? Second point, next boiling point. Please note this. Second is the nature, your physical state. Okay, so now in the case of
teachers, please come down to the office to get the teacher's gift from the child. Happy Teachers Day. Thank you.
Okay, so the atomicity is going to be 4. Similarly, arsenic, other elements also is going to be a This is called tetraatomic. Polyatomic is tetraatomic. Atomicity is going to be 4. Next, the boiling point. Boiling point of the group 15. Is it clear? Very good. So the boiling point is going to be the boiling point. So nitrogen, phosphorus, arsenic, antimony, and bismuth. Okay, just note down the value. I will give the train. Boiling point is going to be 77.2, 564, and this is going to be. You don't need to remember this value. Please look at the values. We know the boiling point. Please note this. Boiling point is directly proportional to molecular mass or molecular weight. This hint you have to remember. Boiling point is directly proportional to molecular mass and molecular weight. But down the group molecular mass increase or molecular weight increase. Increase up to antimony increase. Decrease. Please note this. The boiling point is going to be, okay, boiling point is going to be bismuth followed by 37. This is going to be, in case theta, this is the trend. And the melting point order. Melting point is going to be, please note this, nitrogen, phosphorus, arsenic, antimony, bismuth. The melting point is going to be 63 for nitrogen, 317. You don't need to remember this data, just you have to observe the trend. So initially another increases from the decreaser. Please note this. The melting point from nitrogen to arsenic increases, from antimony to bismuth is decreasing. Is it clear? If you want, you can arrange this one. So which one has the more melting point? First is going to be arsenic, then followed by antimony, then bismuth, then phosphorus, then nitrogen. Okay, you have phosphorus, then nitrogen. So irregular trend. Okay. So if you want, you can remember this point. So this may not be important, but these 2 points are important. Okay. So melting and boiling point. The most important point is all elements of group 15. All elements of group 15. So allotrope. That is allotropic form. All elements of group 15 show allotropic form or exhibit allotropic form except nitrogen. Important point. All elements of group 15 show or exhibit allotropic form except nitrogen. Except nitrogen. Okay. Except nitrogen. Nitrogen form exhibit allotropic form exhibit. Is it clear? Yes or no? So these are the few things regarding the physical property. Is it clear? The first 2 points is diatomic, tetraatomic, allotropic form. This allotropic form exhibit correct, incorrect statement like that. Next, the anomalous properties of nitrogen. Anomalous properties reason or small size, high electronegativity, high ionization energy, absence of d orbital. That's reason. So nitrogen differ from rest of the member of group 15. Anomalous properties of nitrogen or anomalous behavior of nitrogen. Nitrogen is differ from Nitrogen differ from rest of the member of the group 15 due to nitrogen differ from rest of the members of group 15 due to any reason. Small size, high electronegativity, high ionization energy, absence of vacant d orbital, absence of d orbital. Small size, carbonic என்ன anomalous properties எழுதுமோ அதே properties இங்க copy பண்ணிக்கோ. Okay, let's see one by one. Let's see one by one. First anomalous properties. First one. It's most important. Okay. First anomalous property. A exhibit பண்ணனா for reason. Is it clear? First is going to be nitrogen always exists as a diatomic. Nitrogen exists as a diatomic molecule. Nitrogen exists as a diatomic molecule. This is going to be என்ன அப்படினா what is the bond order in the case of nitrogen? What is the bond order? 3. Bond order is going to be 3. அப்ப என்ன bond இருக்கும்? Triple bond இருக்கும். Triple bond. The bond order is going to be 3. Bond order 3. Is it clear? Now we know this concept, chemical bonding. Bond order is directly proportional to bond strength. Bond order directly proportional to bond energy or bond strength. Is it clear? Bond order is directly proportional to bond order for this one is going to be 3. If bond order 3 இருந்ததுனா கண்டிப்பா bond energy is going to be more. Is it clear? அப்ப bond dissociation energy of nitrogen is going to be huge. The bond energy of nitrogen is going to be, what is the bond energy? Be of nitrogen is very huge. The value is going to be 941.1 kilojoule per mole. The bond energy of nitrogen is going to be 941.4 1 kilojoule per is going to be very high. Is it clear? அப்ப இதை ஈஸியா dissociate பண்ண முடியுமா? We cannot dissociate this because bond energy is going to be very, is it clear? Bond energy அதிகமா இருந்தா stability அதிகமா இருக்கும். இப்போ mostly அது என்னவா இருக்கும் அப்படின்னா inert nature இருக்கும். என்ன இருக்கும்? Inert nature. Is it clear? Next, where is the other elements? Phosphorus, arsenic, antimony. It forms single bond. Single bond. என்ன bond இருக்கு? Double bond இருக்கு. For example, in the case of phosphorus எப்படி exist ஆகும்? Tetra atomically, that is P4. P4 ஓட structure பாத்தீங்கன்னா எப்படி இருக்கும்? This is structure of P4. But between phosphorus and phosphorus, என்ன bond இருக்கும்? Single bond இருக்கும். There will not be any multiple bond between phosphorus and phosphorus. This is structure of P4. Structure of lone pair. Between phosphorus and phosphorus, என்ன பண்றது? Single bond. Is it clear? Yes. Okay. And next we go last point. Bismuth forms metallic bond in the elemental state. That will go bismuth form metallic bond in elemental state. Okay, that is metal bond. This is the first point. First point, what do you remember? Bismuth form metallic bond in the elemental state. Okay, these are NCERT lines. Okay, but there is a point you have to remember. Nitrogen always exists as a diatomic. Diatomic na, there are multiple bonds, triple bond, bond order is going to be 3. Bond dissociation energy is going to be more, almost inertness. Whereas other elements always form single bond. For example, phosphorus single bond. Is it clear? Similarly, the other elements. And whereas the last one is going to be bismuth, or is going to be metallic bond, metal bond. Metallic bond is bismuth, another bismuth, metallic bond. Is it clear? Next point, the catenation tendency. Second point, The catenation tendency is weaker in the case of catenation tendency. Okay, catenation tendency is weaker in nitrogen. Catenation tendency is weaker in the case of nitrogen. Why? Is due to, listen here, catenation tendency is weaker. Apna, idhukku meaning enna? Nitrogen self-linking form or tendency is going to be less. Okay, catenation tendency for nitrogen is going to be less or weaker due to any reason or any reason, again chemical bonding. Again chemical bonding. For example, you take this one, okay, nitrogen. Is it clear? Yes or no? Catenation tendency is self-linking property. Nitrogen added. Okay, is it clear? Why catenation tendency weaker in the case of nitrogen? Because another reason. Okay, we have a lone pair, repulsion. Is it clear? Lone pair, repulsions. Lone pair, this is due to nitrogen bond is weaker than phosphorus bond. Nitrogen bond is weaker than phosphorus bond. Okay, phosphorus bond. Nitrogen bond is going to be weaker and compared to phosphorus. Why weaker are they? Because reason inter-electronic repulsions of lone pair electrons. Inter-electronic repulsions of lone pair electrons. அப்போ repulsion இருக்கிறனால இந்த பாண்டை ஈஸியாக பிரேக் பண்ணிடலாம். சிங்கிள் பாண்டை பிரேக் பண்ணிட்டோம் அப்படின்னா inter electronic repulsions of lone pair electrons. ஏன் inter electronic repulsions இங்க மட்டும் இருக்கு, ஏன் இங்க இல்ல? Again chemical bonding. ஏன் இங்க inter electronic repulsions இருக்கு, இங்க inter electronic repulsions இல்ல? Because of size. அப்போ this is because of inter-electron repulsion is going to be more because of small size. Please note this. This is due to small size. அப்போ ஈஸியா என்ன பண்ணிடலாம், சிங்கிள் பாண்டா இருந்தா ஈஸியா பிரேக் ஆயிடும். புரியுதா? அப்போ catenation tendency is going to be less for nitrogen because of inter-electronic repulsions. புரியுதா? Is it clear? அதனால நிறைய nitrogen form or tendency is going to be less. Self-linking property nitrogen கம்மியா இருக்கும் due to this reason. Is it clear? Particularly இது ரெண்டையும் கம்பேர் பண்ணா இந்த bond is a weak bond. எது strong bond, weak bond கேட்டா this bond is going to be a single bond. I am talking about single bond. This is going to be a weak bond when compared to this one. Is it clear? Next point, third point. Third anomalous property. Third anomalous property. Okay, so this is very important property. Here we go. Third anomalous property. Nitrogen has unique ability to form. Nitrogen has a unique ability to form p-pi multiple bond. Very important. Nitrogen has a unique ability to form p-pi multiple bond with itself and other elements. With itself and other elements. Okay, with itself and other elements. Is it clear? Yes or no? Whereas the heavier elements, for example, phosphorus, arsenic, antimony, bismuth. Phosphorus, arsenic, antimony, bismuth. They do not form p-pi multiple bond. Always there is no p-pi multiple bond. Your previous year question, please note this. Okay, so if you have p-pi bond form, for example, you take nitrogen oxide, nitrogen dioxide, ஏன் p-pi இதுல double bonds இருக்கா? ஏன் double bond form ஆகுது? Whereas other elements ஏன் form ஆகல? Because again size. Again is going to be size. In the elements are both small size and high electronegative. Is it clear? Whereas phosphorus size is effective overlap. Multiple bonds form. Small size are effective multiple bonds form. Is it clear? That is the reason. Now nitrogen form P pi multiple bond. That means it will form nitrogen other elements. This form multiple bond, triple bond form. Plus other elements form. For example, NO, NO2. These are the examples. So it will form multiple bond with other elements. And the other elements small size are more electronegative atom. That is the point. Is it clear? Next, the last point is going to be the fourth point of anomalous behavior. Fourth point of anomalous behavior. Okay? So nitrogen shows maximum valency. What is the answer? Maximum covalency. Maximum valency. 5. Maximum second period elements maximum valency 4. Second period maximum valency 4. Is it clear? Yes or no? Huh? Yes. Yes or no? What about ammonium ion? What is the covalency? 4. Is it clear? Maximum valency 4. Is it clear? It cannot form more than 4 bond because you have 1s 3p. 1s 3p. About 4 orbitals are 4 orbitals and 4 bonds. Is it clear? Yes or no? So nitrogen or maximum valency is going to be 4 because of absence of vacant d orbital. Okay, because of absence of vacant d orbital. Upon nitrogen there is no d orbital, it cannot go. For example, if your question is absence of vacant d orbital. The reason is absence of vacant d orbital. For example, suppose we know that PCl5, NCl5 again chemical bonding. NCl5. This exists. PCl5 exists. Because availability d orbital. Availability of? What about this one? This exists? No. This exists. Why this NCl5, NCl3 exists? Yes, because of maximum valency 4. So 3 exists. Is it clear? 5 exists. Yeah. Because of absence of d orbital. Absence of d orbital. Is it clear? That's the point. So NCl5 exists. NCl3 exists. Is it clear? This is purely because of absence of d orbital. Is it clear? Next important point. Next. So next point, second important point. Absence of d orbital. Absence of d orbital. Thus, nitrogen cannot form. Absence of d orbital. Nitrogen cannot form. It's a very important point. So nitrogen cannot form. Listen carefully. P pi d pi bond. What is this? Nitrogen form P pi d pi bond. What is the P? Nitrogen can form which bond? P pi bond can form. Example: N2, NO, NO2. This is form oxygen p orbital. Nitrogen p orbital sideways overlap pi bond form. Is it clear? Whereas this form P pi d pi form agadu. Yes or no? Because nitrogen n orbital kedayadu. D orbital kedayadu. Please note this point. Appo nitrogen, listen carefully. Appo nitrogen, phosphorus. Nitrogen, for example, nitrogen P pi form on keta yes. Adhe mari P pi d pi form on keta no. Is it clear? Please note this. அப்போ எது ஃபார்ம் ஆகுதுன்னு கேட்டா p pi d pi. இதுக்கு மீனிங் என்ன? What is the meaning of this one? What is the meaning of this one? ஒரு pi bond ஃபார்ம் ஆகுது. எது ஓவர்லாப் ஆகும்னு சொல்லிருக்காங்க? p ஆர்பிட்டாலும் d ஆர்பிட்டாலும் ஓவர்லாப். எப்படி p ஆர்பிட்டால் d ஆர்பிட்டால் ஓவர்லாப் ஆகும்? இது d ஆர்பிட்டால், இது d ஆர்பிட்டால், இது p ஆர்பிட்டால். சைட்வேஸ் ஓவர்லாப் ஆகுமா? சைட்வேஸ் ஓவர்லாப். இந்த ஓவர்லாப் இது p, இது d. இதுக்கு பேர் என்னது? p pi d pi ஓவர்லாப். இது கிளியர்? p pi d pi ஓவர்லாப்னா ஒரு p ஆர்பிட்டால், ஒரு p ஆர்பிட்டால் ரெண்டுமே சைட்வேஸ்ல ஓவர்லாப் ஆகும். This is called p pi bond. என்ன பாண்டு? புரியுதா? அப்போ இதுல இருக்கிற d ஆர்பிட்டாலும் இதுல இருக்கிற p ஆர்பிட்டாலும் என்ன ஆகும்? ஓவர்லாப் ஆச்சுனா. புரியுதா? அப்ப நைட்ரஜன்ல என்ன இல்ல? d ஆர்பிட்டால் கிடையாது. Is it clear? அதோட ஓவர்லாப் ஆகாது. p ஆர்பிட்டால்ஸோட ஓவர்லாப் ஆகாது. Is it clear? That is the point I wanted to say. புரியுதா? Please note this. So nitrogen cannot form d pi p pi bond, whereas the heavier elements can form p pi d pi bond. For heavier elements no? Heavier elements no? Phosphorus, arsenic, antimony. This is the diagram draw பண்ணிக்கோ. For phosphorus form ஆகுமான்னு கேட்டா answer is yes. Phosphorus can form p pi d pi bond. P pi d pi bond. Is it clear? Is it clear? Example. எப்படி சார் ஃபார்ம் ஆகும்? Example for this is going to be phosphorus. R group is going to be any R group. R is going to be 3 times. This is going to be oxygen. Listen carefully. So first is going to be sigma. First is going to be sigma. Listen. First is going to be sigma. Second bond என்ன ஃபார்ம் ஆகும்? pi ஃபார்ம் ஆகுமா? pi னா இங்க d ஆர்பிட்டால் வேணுமா? அப்ப இங்க இருக்கிற d ஆர்பிட்டாலும் ஆக்சிஜன்ல இருக்கிற p ஆர்பிட்டாலும் சேர்ந்து சைட்வேஸ் ஓவர்லாப். இந்த மாதிரி ஓவர்லாப் ஆகும். அப்படி ஓவர்லாப் ஆச்சுனா செகண்ட் பாண்ட் இஸ் கோயிங் டு பி தி pi bond. இந்த pi bond because of p pi d pi. p எங்கிறது வரும்? ஆக்சிஜன்ல இருந்து. d எங்கிறது வரும்? பாஸ்பரஸ்ல இருந்து வரும். Is it clear? Please note this. Okay, the other examples also where we have R3 phosphorus. இது என்ன வேணா இருக்கலாம்? R group, alkyl group. This is going to be CH2. Listen carefully. First bond is going to be sigma. Second bond எப்படி போகும்? Phosphorus இருக்கிற d ஆர்பிட்டாலும் கார்பன் இருக்கிற p ஆர்பிட்டாலும் சேர்ந்து second bond form. That is the meaning of this. Is it clear? Is it clear? Yes. And it can also form. It can also form d pi bond with transition metals. Phosphorus also can form d pi bond with transition metals. Transition metals. So what is the important thing in this? This point is very important point. Okay, this point is very important. Phosphorus என்ன bond form ஆகும்னு கேட்டா d pi p pi or p pi d pi. Is it clear? இது form ஆகும்னு கேட்டா yes. Okay, examples பார்த்தோம். Similarly d pi d pi எதோட form ஆகும்னு கேட்டா with transition metals. With அப்ப phosphorusல இருக்கிறது இங்க என்ன ஆர்பிட்டால் இருக்கும்? மெட்டல் இருக்கிற ஆர்பிட்டால்ஸ் வரும். என்ன ஆர்பிட்டால்ஸ் இருக்கும்? மெட்டலோட ஆர்பிட்டால். Is it clear? எழுதுங்க. When the compounds like triethyl phosphine and arsenic, triphenyl, triethyl phosphine, arsenic, triphenyl act as a ligand. இந்த ligands இருக்கும்போது என்ன bond form ஆகும்? இதெல்லாம் ligands இருக்கும்போது it will form d pi bond. Please note this. Okay, இதோட d pi bond form ஆகும். இது ligands, இது மெட்டலோட d pi bond form. Is it clear? Yes or no? அப்போ other metals என்ன form ஆகும்னு கேட்டா what is the answer? d pi p pi form ஆகும். as well as என்ன form ஆகும்? d pi. phosphorus எது மட்டும் தான்? நைட்ரஜன் எது மட்டும் தான் form ஆகும்? Only p pi மட்டும் தான் form ஆகும். That is the point I wanted to say. Is it clear? Please note this. இது லைகண்டா இருக்கும்போது மட்டும்தான் it will form இந்த மாதிரி ligands. இந்த மாதிரி ligands இருக்கும்போது it will form d pi bonds. Is it clear? Yes. Is it clear? Yes. So these are the important anomalous property. Any anomalous property? Can you list first one? First anomalous property. Diatomic. The rest are polyatomic. That means it can form triple bond. Other elements form single bond. Second property, catenation is going to be less because of inter-electronic repulsion on the nitrogen. Why inter-electronic repulsion in the nitrogen? Because of small size. And this is the third point. P pi bond. What bond? Whereas other elements P pi D pi as well as D pi D. Is it clear? Yeah, this will stop.